Hello everybody, this video is about the explanation artificial intelligence line with decision tree regression in Jupyter notebook. Let's go to Jupyter and start working. So as usual you need to import the dataset. To do that, let's say loading the dataset, and here we need to import pandas library. So import pandas as PD, and then need to read the dataset. Dataset. So call it my data equal to pd.read underscore comma separated value parenthesis quote e. The dataset is found in this directory sltech docs /data /lake dot comma separated value. Run. Error in loading the data. Error. Problem of directory. Okay, I see here. Instead of colon is semicolon here. So, sorry about that. Okay, the data is red. So let's explore it a little bit. Exploring the data set. Let's have an idea about the first 5 rows of the data set. Or heads, let's see it. So my data dot heads. This is what you get. To have an idea about the basic descriptive statistics. So my data dot describe. So here what you have. You have excuse me, my touch screen. You have in heads you have the head of the columns, the title of the columns, the T for time, ET stands for evapotranspiration, SH is soil moisture, AT is air temperature, ST is soil temperature, P is precipitation, SM stands for soil moisture and LL stands for lake level. So LL here is our target variable, and from EG to SM we have our features for input variables. So in the description, the basic statistics, this is what you have. And if you want to have an idea about the dimensions, so I have my data dot shape, dimensions. We have 240 observation for 8 variables. So including T, we are going to drop T. Okay, now let's prepare our output and input data. Preparation. Let's have the output first. Our target is Y. So Y, as I said, is lake level. So for my data, we take lake level, LL. Let's have an idea about the shape of Y. So we have a column of 240 rows or observations. So this is the dimension. Okay, let's have an idea about Y dot head. This is the column of Y, LL. So the input variables or features, X equal, from my data we are going to drop the level and T. So drop T, the time, then lake level, then comma axis equal to 1. So let's see X dot shape. Have our 6 variables, 240 rows. X dot shape, dot heads. These are the features, the first 5 rows of the features. Okay, now let's split, but before that you need to run the variance inflection factor analysis and the scale, the features before the next steps. Okay, the next step is splitting the dataset into training and testing data set. Testing data set. For this purpose, you need to import the function train test split. From scikit-learn.model selection, model underscore selection, import train underscore test underscore split. Then after that, we proceed to splitting the data. Splitting with double T. So we have X train, X test, Y train, Y test equal to train test split. We have X, we have Y, we have the test size, take it to 25%, random underscore state, put it 30, then I want the shuffle to be true. Shuffle equal to 2. Need to shuffle the data. Okay. Checking the dimensions. So print X train dot shape X test dot shape Y train dot shape Y test dot shape X underscore instead of dash here. Excuse me. So this is what we have in our training and testing data. As dimension 180 observation for training and 60 observation for testing. Okay. So now we are going to proceed to the decision tree regression modeling. To do that, you need to import necessary libraries and functions. So from the first one is run decision tree regression. So from scikit-learn dot tree import decision tree regression. Then we need matrix from scikit-learn dot matrix import the R square, so we need R2 square. We need the mean absolute error, as well as mean square error. We also need to run the cross validation, so from scikit-learn.model selection import cross val score. Model selection import cross val score with underscore. We need to import numpy as np. Import numpy as np. And then from numpy we need to import absolute, because we need absolute values for the cross-val score result. So from numpy import absolute. Then we may have some error messages popping up, so we need to ignore them or suppress them. So we import warnings. And then warnings dot filter warnings parenthesis cut ignore. Good. These are what we need as libraries and functions to run our decision tree regression. So this is the modeling part. The first thing we need is the instantiation. So let's call it model. So model equal to decision tree regressor. We have the parameters with their arguments here. We have max def equals 6. We have max leaf node equal to 50. leaf equal to 2. And samples leaf equal to 2. And the mean samples split equal to 6. Okay. Max depth 6, mass leaf node 50, mean samples leaf 2, mean samples split 6. To get these values, please let me put it here. Run your own hyper parameter tuning to get the parameters argument values. Okay, this is what I got from my own analysis, but when you have your data set, you need to run your own hyperparameter tuning to get these values: the max depth, the mean leaf nodes, the mean sample split, and the mean sample leaves. So of course you need to get them from your own analysis, tuning your own parameters using the data set you are using for your research. Okay, now that you have our model instantiated, you need to fit it in the model on the training dataset, or using the training dataset. So let's call it regression 3 equal model dot fit xtrain ytrain. Sorry, my keyboard is getting older, the whole computer is getting older, so I have to press hard to get the letters. So okay, now the model is already fit, so we need to evaluate the performance of the training model. For this we need to first predict using the training data set. So let's say regression 3 prediction on the training data set equal to regression 3 that predicts x train. Click on x train. Now after predicting on the training data set, we are going to print the R2 score, or the R squared. The training R squared is R2 underscore score y train, and its corresponding predicted. So RT predict 80%. let's have an idea about the mean absolute error on the training data set. The training MLE is mean underscore absolute underscore error, again in y-time, and its corresponding predicted value. Y15. Now let's print the mean squared error for training data set. Training MSE is mean squared error by train .04. So let's have the testing model performance. As usual, we need to predict, so RT predict on the testing data set for RT that predicts X test. And then we print the testing R squared. And to score y test RT pred TS. About 40%. Print the testing in absolute error is an absolute error y test RT TS. And then print the testing with E is mean squared error by test RT by TS. Okay. Now let's have an idea about the K for cross-validation. K for cross-validation. On the training data set. Call it CVTR, cross-validation training. So cross underscore val underscore score parenthesis X train need the model first. RT. Let's train. Weight train. The scoring, I take min score error. So we need to take the negative of it here, and then after that change it. Negative min squared error. Then number of false 10 false. So these are the values for the respective false in negative. First fall with the mean score error to the 10th, but we need the absolute mean score. So the absolute mean training score is, so I print it. Absolute, and keep that mean, and then we have our CVT here. And 15. So let's have on the testing data set. Let's call it CVTS. Cross underscore one underscore score our model, and then X test, then Y test, and we have our scoring, negative, mean squared error, then number of folds 10, let's have an idea about this VTS. Then the mean score, absolute mean score, and the absolute mean testing CV score is absolute of the mean of CVTS 0.16. So this is our regression tree model for the line, which is now in this section line. which I put it already. It stands for local interpretable model diagnostic explanations. So to run Lime, you need to install Lime by typing. You go to Conda or go to Anaconda prompt. Or in terminal here in Jupyter, Conda, install Conda dashforge to column line. In Anaconda, prompt, PIP install line, in command prompt, send the prompt. Or you can go to when you are here, go to new, sorry with my screen, the computer is really causing problems now. Sorry about that. Yes, I apologize. My computer is causing me problems. So you go here and you come down here, you have terminal. You click on terminal, it opens you. This where you can also type the commands. Yeah, Conda or PIP install, and you get your line installed from here as well. Or you go to Anaconda prompt, or you send this prompt. Okay, sorry. So let's come back to Lime. So once you do that, you come back to Jupyter, and you need to import Lime tabular explainer. By typing from line underscore tabular import line tabular explainer. Good. Once you do that, now you need to create explainer object on the training data set. So explainer equal line tabular explainer parenthesis x underscore train get values feature names equal x train dot columns. So the name of the features is in the columns of x train. We have what's named, and we have the class names. Our class name is our y, our target variable. Verbose equal to true, and then we are running in regression mode equal to regression. So this is our explainer, and it has to be done using the training data set. Once we do that, we need to explain predictions. So as I compare the performance of model on training and testing data set, we are going to do the same thing here. Explanation on the training and the testing data set. So let's say explanation of instances again for individual prediction. Using on the training data set. So let's have our instance, for instance, I equal to, let's say, 20. This is the index of the instance to be explained. So we take the X train, we have 180 observations, so we take index 20, and we want the explanation of the prediction of this index. So we run it, and we have the explanation. So the explanation is like explainer, or explainer we already create. Dot explain, underscore instance, parenthesis, explain, get values, and the values, sorry, for I, or I we have above, regression 3 dot predict, prediction for I, number of features equal to 6. So this is what we get: intercept, prediction local, and the right. So if you want to check the instance, and the prediction as well. So we type print the instance is I equal 20, we print 20, and then we are going to print its corresponding prediction based on the regression 3 predict TR. Checking the prediction, and we print the prediction. Is RT dot, sorry, RT dot predict, no, RT underscore predict TR I. So you compare here, this is ready for this one. Now how you check the instance, you take the prediction. You can change the instance to, let's say, 40. Then you run, see its prediction, right, is 282.00.38.889. You the instance 40, you check the instance, then you check also the prediction using this code RT/TR. See, is 282, the same as this one. So we cannot keep doing the same thing over again. That's why you need to go to the second method, on which consists of predicting, on explaining the average, the average prediction, instead of going through each of them. Let's for this I equal 20, let's have some plots of it. we want to show the explanation table. The explainable table, the type explanation dot show underscore in underscore table, no sorry, in notebook, and then parentheses show table equal to show underscore table equal to show. Okay, this is the explainable table for I equal to, we change to 40. This for I equal to 40. So if we change I and we run the code here, you are going to get its corresponding explainable table. So here you have the explanation of the average prediction for the world training data set. Before it was for instances or individual predictions, now is for the world training data set. So we'll have a list of index on the training data set. So train ind for index underscore list equal, in this list we have the indexes of x train dot index x train dot index dot to list. Then have a dictionary as of now empty, still on the training data set. So train dict equal to curly bracket and then we are going to loop. So for n in our list of index, list of indexes for the training data set, we are going to have the explanation explainer dot explain underscore instance parentheses x train dot log brackets n dot values. It's not I, the whole n, values for all n, and the regression tree dot predict. The number of features is still 6. Non-features equals to 6. Number of samples equal to, let's check here, x train dot shape 180. Yes, 180 and the 6 variables. If you are not sure, you just type here. So known feature 6 and the number of observation 180. So non-sample equal to 180. Okay. Then we'll have an object A. To store the explanation as list, just underscore list. Underscore list. Then we put it in the dictionary. Transit brackets and equal to A. And delete this. Okay, let's run. So this is what you have for all the 180. So you have intercept, prediction, local right, prediction, and so on. From the first to the last. Next. Intercept, prediction, local right, intercept, prediction, local right, and so on. Repeating. Okay, now we are here. If you want to let's type explanation. Sure, this is what you have for the world training data set. Let's showing explainable table for the average prediction. In the world training data set. As we did before, we type some quotes here. Show underscore in notebook. Show table equal to true. You have your explanation table for the average prediction. Above is the explanation table for the instances. Here, let's have an idea about the feature and purpose. You need to import matplot as PLT. then with plt.display dot context. For context here is ggplot. Sorry, we need a parenthesis first, and then quote and dplot. Okay, colon. We have explanation. Explanation, yes. Thus as pyplot underscore figure. As pyplot dot as underscore pyplot underscore figure. Let's display as context. Let's say no. Let's check. No, sorry. Dot style. It's not display. Style. Dot style. Dot. So this is the feature importance for the values. You see the impacts. The features is positive, negative impacts. Negative impacts here, the positive impact to the left. And you see here the negative values, the positive values on this side. These are the features with their values, the ranges, the values of. So here you see here the positive and negative, and you see the predicted value, the main marks, and then you have the feature and the values in this table. So this is for the average. You can have this plot also above for the instances. Okay, now if you want to output the feature importance as this, you can do as well. Dot as list explanation dot underscore dot as underscore list. So these are the values. See in the ranges you have here. And you have the values here instead of the plot. See, take the last one. 25.37. This temperature less than air temperature less than equal to 26.45, and this is its importance. And you see here it's plotted as negative here. Here you have the value. Here you have the value instead of plot. So if you want the plots, you take this. It's up to you. If you want the values as a list, print the list. If you want as a dictionary, yes, the dictionary. So as map. So this is what you get. If you want to retrieve the thing, these are the most important parts you need. Yeah, you need the plots. You need this plot, you need to save it. If you need the feature importance as plot, you will have this as well. And if you need values, you have as list or as dictionary. You can do the same for the above mentioned vocal predictions. So if you want to save your HTML file, you just type explanation dot save to file, save underscore to underscore file, File version 3, underscore crane dot html, and this has to be in quote as well. So you select here, you put in quote, and you run is going to save it for you in wherever you have your Anaconda files. This plot you can also get it as an HTML. This plot is already an HTML file here, but for the sake of time, let's make it short. This is going to give you the same thing. Okay, so let's go to doing the same thing on the testing data set. Over, it was on the training data set. Now on the testing data set. We'll do the same thing. Explanation of individual predictions. Of instances for individual predictions. We still have our I. In the testing data set, you have about 60. So the indexes would go from 0 to 59. So let's say I equal 10. And the index of the instance to be explained. Run, and then have the explanation. XP equal explainer and dot explain underscore instance. So the same explainer we have we set above using the training data set. So this time here for the testing is going to be xtest dot values. This time I. Then regression tree dot prediction. Then null features is still 6. So in testing training data set we have 6 variables or features. So this is for I equal 10. This is the explanation. So checking the instance. And the instance is I 10. Then checking the prediction. Print and the prediction is this time is prediction true.predict no sorry RT underscore provided TS I. We run and we compare the right here with this same for I equal 10. This is what we get. If we change our I to 15 and we run, sorry, I equal 15, the explanation, and then we check the instance 15, and then compare. Look at this. This for I equal to 15. This for I equal to yes 15. This for I equal to 10. So when we run, this you have for 15. So you compare this with this exactly. So instead of doing that over and over again, that's why we look for the whole training data set or all testing data set. If you want the table, to see the table, open. That show in underscore notebook. Parentheses show underscore table equal to true. Okay, this is for the instance 15. Okay, now we are going to go through the whole data set and have an idea about the average prediction. Testing data set. Here now we have a list of indexes for the whole training data set, testing data set, sorry. X test dot index dot list. And then for the dictionary, just set to empty the bracket. Then for the loop again, and in can index list explanation equal to explainer dot explain underscore instance parentheses, this time x test dot log brackets and dot values part dot predict non features equals to 6 number of sample equal to 60. In the testing data set you have 60 observations. If again you are not sure, you type xtest dot sheet, you have the last two informations. So 6 for number of features and 60 for number of samples. And then you have a list of explanations. It's a list. And then keep in the dictionary. second. Next dictionary st equal n. Okay. For n in 10 nx and test. Okay. Test instead of 3. Okay. Sorry, no parentheses here. Good. Okay. So this is for the whole 60. Observations. Now to have the explanation table, the explainable table. We have xp.show in notebook. Show table equal to true. Okay. Now we have the course above on how to have the other parts as well. But one thing needs to be mentioned here. If you need the local and the global predictions, I didn't put that for the one above, but yeah, printing the average local in the printing the average local and the global predictions. So print the local prediction is explanation dot local underscore pred. This is the local, the average local prediction. Now is print the global prediction is regression dot predicted value. So this for the average. If you want for the instances, you put above. I did not do that for. You can just copy. This is for the testing data set. You can come here for the training data set. We need to run this first. This for the whole training data set. We run it. When we run it, we'll have our XP here run. So it's we have this the plot, and then nothing changes. After this year, before we save it, we can add a row here and put the predictions, the local prediction, and the average local prediction, this for the training. So you have the values for the training here and the testing below. So let's run this again. For the testing data set, let's run and save it. Run this. Let me make sure that this is what we will be saving. Okay. Done. 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 Okay. Now to save the HTML file. exp.save underscore to underscore file parenthesis code line dash regression 3 underscore test this time dot html. So and we run it. It's saved. So let's go to where I put my Anaconda files and check it. We need the two files to be there. Use them. I have PC, C, as administrators. That's where my Anaconda, my Jupyter notebook files, everything is. So we need the line RT. Yes. Line RT train, line RT test on 9/17/2024, 9/17. So let's open this. This is on training data set. Let's go back and open on testing data set. So here you have the two plots. For the average predictions, and this is the end of the video. Thank you very much for watching. I hope this will help some who are doing research to make progress in whatever they are doing. So again, thank you very much.